Hello everyone. My name is Qiao Xue. This is my presentation for EEL 6509 Wireless Communication class. My subject is about smart antenna, and what I did is the comparison of different angles of arrival estimation methods in smart antenna techniques. Now let's introduce about smart antenna. Smart antenna is any antenna array with precision signal processor. It can adjust the beam pattern to the signal it wants, and it can decrease the noise which interfere with the signal. Therefore, it is important for smart antenna to compute the angle of arrival accurately. Why we should compute the angle of arrival and how it comes? A signal source may have several transmitters, and these transmitters may have many possible propagation paths, and these paths have different arrival angles, and these transmitters may work at the same time. So it is important to know which one is working, and we can use the angle of arrival to determine which one is working, and this project is to compare the different ways to compute the angle of arrival. Now let's introduce a concept about antenna correlation matrix. For the output of the antenna array, it can be expressed as follows, and in which the xk equals a times sk plus nk. K is the sampling time, and w is the weight of the antenna array. Sk is the input signal vector at time k, and nk is the noise. A is the matrix of steering vector. The correlation matrix of antenna array is defined as follows, and by using the correlation matrix, we can create a function called pseudospectrum. It's a function to the angle of arrival, and it gets to the maximum when it's at the angle of arrival. So we just need to compute the maximum where the pseudospectrum get the maximum, then we can get the angle of arrival. Now let's introduce the first method we discussed. The first method is Bartlett method. The pseudospectrum can create it like this, and the acid is the steering vector of the antenna array on the direction theta. And the second method is Kaplan method. The purpose of this method is to maximize the SIR, and the array weight matrix can be computed by this form, and we plug the weight matrix into the pseudospectrum. We can get the pseudospectrum like this. And the third method is linear prediction method. This method is to minimize the prediction error between the number m antenna array element and the actual output. So we can find where the error get to the minimum, and we find the weight matrix. The weight matrix solution is like this, and we plug the weight matrix into the pseudospectrum. We can get the pseudospectrum like this. And the fourth method is called music method. It's a short term for multiple signal classification. and the correlation matrix of a 10 array is in this form, which means the noise is in correlate matrix, and we can compute the eigenvector and eigenvalue of the correlation matrix of a 10 array. Then there is m minus d eigenvectors related to noise. M is the number of a 10 array element, and d is the number of arrived signal. Then we select the eigenvectors which has the minimum eigenvalues, and because the noise signal is uncorrelated, so the noise signals has the minimum eigenvalues, which is m minus d eigenvectors. Then we can form a subspace formed by these eigenvectors, and these eigenvectors is orthogonal to the arrival steering vectors. Therefore, we can create a pseudospectrum like this. We put the arrival steering vector times the eigenvector, which is 0. Then we can get the function to the maximum at the arriving of angle of arrival. These are the result of the test. We have the first input set is in the direction of 60 degree, 45 degree, 30 degree, and 135 degree. We can see that the Bartlett method, it can distinguish from the 135 degree with the remaining, but it cannot distinguish between 60, 45, and 30 degrees. However, the remaining algorithms, they can effectively distinguish between these 4 input angles. However, except music algorithm, there are some small peaks in the Capon algorithm and LP algorithm, which may cause some error output. And for the input set of the second set, we can see that the Bartlett algorithm still cannot distinguish of the first 2 angles because they were very close to each other, but the remaining algorithm, they can distinguish between the pi over 36 degree, and there is still some small peaks in the Capon algorithm and LP algorithm. Therefore, we can draw the conclusion is that the Bartlett method is the worst method among these 4 methods, and both the music method, Capon method, and LP method, they can distinguish the little difference in angles, at least 1 over 36 pi. And the music method has the best output because there's no some small peaks in between these angles, and we can do better because this project only discussed one-dimensional case, and there is still multi-passes interference, and we do not consider in this case. And we can do more tests to explore how small the difference in angles that music's, Capon, and LP method can do. and we can add the we can add different noise into the input signals to see how these methods work out. And that's the end of my presentation. Thank you so much.